All right, everybody, we're going to be looking at balancing chemical equations this week and next week. So let's go ahead and see how this is done. And this is just how I like to do it. I mean, other people have other types of methods, but they're all pretty much the same sort of way. So here we have a chemical equation. We have Mg plus O2 yielding MgO. So the first thing I got to do is I like to divide it out so I keep my sides separate. So I have the reactants and I have the products. So on the reactant side, I have Mg and I have O. I know that's one thing because it's a capital letter with a lowercase letter. So that's going to be Mg. So how many Mg's do I have? I counted up. I only see one because there's no number next to it. So I know there's only one. And with oxygen, there's two. Well, this side will have the exact same things as this side because of the conservation of mass. So we have Mg and we have O. And on this side, I have 1 and 1. So obviously that is not quite even. So the next thing I need to do is decide what can I put for my coefficients that's going to help me balance this out. So I know I have 2 oxygens here. I only have 1 here, so I'm going to start there. So I'm going to put a 2. So once I put a 2, I now have 2 Mg and 2 oxygens. Come back over here, my oxygens are now equal, but my Mg is not. But what number can I put here that multiplies by the subscript, which there's none there, so that's a 1, to give me 2? Well, I know from my math that 2 times 1 is 2. So I do that. Now I look. This doesn't have to have anything there. Unless you're in the PhET simulation, then you'll have to put 1 just to show that something's there. We don't need to though, because we already know we have it. So now we look, we have 2 Mg, 2 Mg, and 2 oxygens. This will multiply by there, this will multiply by there, this will multiply here, this will multiply here. I know it looks like there's no number there, but essentially that's a 1. And we end up with a balanced equation. So it takes 2 Mg plus 1 molecule of oxygen that will yield 2 molecules of MgO. Okay, so that's the first one. I'll go ahead and do one more just to show another model. So I'm going to go with, let's go with KClO3, and that's going to be decomposing into KCl plus O2. Notice I've left space so that I can put in my coefficients, because that's the only thing I'm changing. I'm not changing any of these subscripts because that would change what it is. So I divide it out. I've got K, I've got Cl, and I've got O. And I keep them at the same level so it's easy to compare. And so I look and say I have 2 oxygens here, 3 oxygens here. What's the common number that could help me out here? Well, I think I'm just going to use the opposite number, so I get it up to 6. So I'm going to go 3, I should count that out first. 1, 1, and 2, and then 1, 1, and 3. So now I put the 3 there, so that's going to change it. So 3 times 2 gives me 6. Nothing changes there. Haven't done anything here yet, but I know that 2 here would give me 6, so I'm going to go 2 times the 3 gives me 6. But I have to also multiply here, so that changes that to 2. And I have to go here for Cl, that changes it to 2. Is it balanced? No, because I have 1s on this side. But that's an easy fix for this particular problem. I go ahead and go 2. That's going to give me 2 Ks and 2 Cls. And look. 2 and 2, 2 and 2, 6 and 6. I am now balanced. So that's a very quick tutorial. We'll be doing a whole lot more of this in class. For those of you who are e-learners, you can go ahead and watch the other video too I've included to see other science teachers, other scientists going ahead and balancing out chemical equations. All right, have a great day.